All right, guys, what we're going to do is we're going to look through this Friday Madness. This first one. So we have a charge going down the screen. So I take my right-hand rule, current, field, force. So the current is going down the screen. The field is coming out at me. So my thumb is going to the left. So I'm going to draw that. So that means the force, when it enters, will be this way. So if I think about what path it'll take, it'll go like this, or maybe it does a whole loop. If I'm just drawing a part of a circle, right? If it was a tighter corner, it would do this. If it was a less, right, it would just be more bigger radius. If it was going twice as fast, what would happen to the radius? It would be a bigger radius. It would actually be times 2. Because in class we talked about radius is mv over bq. So if my velocity is twice as big, my radius is twice as big. All right, number 2. If there's 2 amps going through the 15 ohms, I'm just going to draw that. There's 2 amps going here. What is the voltage on the battery? That's it. So if there's 2 amps, well, that means right here, this is a potential of 30. But the one above it would be 10 because they're in series. So together, both of those on that side are 40. Well, if I look here and here, if it's 40 on the right side, it's 40 on the left side. Well, if we have 40 volts and 20 ohms, that will also be 2 amps. So I get 2 amps on that side and 2 amps on the right side. So together, that is 4 amps. So if there's 4 amps, that means this would be 40 volts up here. So what you have is a battery. In this first bit, it drops 40 volts. Then it has the parallel branch. And this one drops, 40 volts. So what is the battery? 80 volts. Because Kirchhoff's loop rule is every path, the change in potential is 0. So if the battery pumps it up 80, it'll drop 80 on one of those paths. Okay, we're doing number 3 now. I'm going to create some space for us. Okay, so we'll see if I can get some space. Let me clear this off. Okie dokie. So over here. So this one right here. So when the switch is first closed, what's the current? So the idea one is that when a switch is first closed, you are going to have maximum current going onto that resistor. Sorry, onto that capacitor. So if that's 120 volts, 20 ohms, 40 ohms, and back. Well, at the beginning, that capacitor acts like a wire. Well, if I have a wire, all of the current is going to go this way. None of it is going to go through that. So really what my circuit is, at first, is just this. 120 volts, 20 ohms. So V equals IR. 120 equals I times 20. So the current will be 6 at the beginning. Okay, that's part A. Part B, we're going to look at how is part B different. So part B, after this has been closed for a long time, a lot of you on the test had a wrong answer, but it was a good answer. I knew what you meant. You said 0 amps. Not completely true. You're right. Going through here is 0 amps. Going through the capacitor is 0 amps. It basically is blocking the current. It's like a barrier. Okay. So this is 20 ohms. This is 40 ohms. And this is 120 volts. Really what you have is this. 20 ohms, 40 ohms. So if I do V equals IR, I get 120 equals I times 60. So my current is 2. It was important. Whenever you have capacitors and circuits, when they're uncharged, you get a larger current. When they're fully charged, you have less. Because there's less location for the charges to go onto. Let's get me out of here. So now, last one. What's the potential in this capacitor at this point in time? Aha! This is an idea that I saw people were having a hard time with on the exam. So that's why I'm putting this one here. When it's fully charged, here's my capacitor. This is 20 ohms. This is 40 ohms. And what we know is the current going through this is not 20, 2 amps. Current going through here is 2 amps. And the current going through here is 0 amps. Okay. So here's the idea, is that this capacitor right here is in parallel with this resistor. This resistor has 2 amps, 40 ohms. If I do V equals IR, I get 80 volts. If that's 80 volts, the capacitor is also in parallel with it, so that capacitor will have 80 volts. In this problem, I was trying to drive home that point. From here, we could ask lots of different questions. We say, what is the charge on it? What is the energy on it? I think those are the two big questions I would ask. Is how much charge is on it and how much energy does it have? So I think that would be a question that would be asked. So, but the idea is that it's in parallel with it, so they'll be the same. All right, guys, thanks for tuning in. Have a great weekend.